Do you remember y equals mx plus b method of graphing a line? We start at the y-intercept and use the rise over run as our... So, f of x equals x. The first example, we're going to do a table of values. And after that, we're not anymore. Okay? So, if negative 3 goes into this function, what does f of x equal? Negative 3. If negative 2 goes into this function, what is negative 2? It's just whatever the x is, the y is, right? Does everybody understand f of x is just a fancy name for y? I even have a poster back there that says that. Negative 1, 0, 1, 2, 3. I'm going to plot that. But if we knew anything about how to graph a line, we didn't have to do this table of values. We knew that all we had to do is put a point on 0 of our y-intercept and go up 1 over 1. There's my second point, and then I draw a line. Does everybody remember that from grade 10? So, now we're going to do g of x. It says g of x is the absolute value of the input. So if the input x is negative 3 and it goes into the g machine, what comes out? 3, the g machine. Negative 2 goes into the g machine, what comes out? 2. Negative 1 goes in, 1, 0 goes in, 0, 1 goes in, 1, 2, 3. Let's plot this. I'm going to plot it in a different color. So, negative 3, 3. Negative 2, 2. Negative 1, 1. 0, 0, 1, 1, 2, 2, 3, 3. This line now looks like a V.
Right angle.
Does everybody see it looks like a V? Okay, now, do you remember the definition of an absolute value from yesterday? The absolute value of x is equal to two different things when x is greater than or equal to 0 and when x is less than 0. It's equal to positive x when x is greater than, meaning if you put it in, you're just going to get itself, right? When it's less than 0, it's going to equal negative x, meaning it'll switch the negative sign to become positive. So, knowing our knowledge about lines, does everybody see? Here is the separation between positive. Maybe I'll use a highlighter or something here. There's a highlighter. So does everybody see right here? Oh, that's way too, well, no, that's okay. Does everybody see that's the separation between positive and negative numbers, yes? Okay, so the way we should be looking at this green V is the function is that positive line y equals x when it's positive. Do you see that? And then on the other side of the line, on the negative side of the line, do you see it's equal to negative x? Well, how would you graph a line that's negative x? A point on 0, instead of going up 1 over 1, what are we doing this time? Down 1 over 1. Here's our second point, here's our line. Do you see there's the line? But that line that goes down to the right only exists on the left-hand part of the graph. So that's where the definition of absolute value and what we're doing here really works. But there's really a shortcut if you look at this. If I were to graph what's inside, inside the function, what's inside the function, this line, this blue line, what do I know about absolute values? It's always positive, right? So, because this refers to a fancy name for y, it's saying all the y values are positive. So look at this. Even though x is negative, it should have been down here, but y is negative, now is positive. Y is negative, now it's positive. Y is negative, now it's positive. Do you see? All I'm doing is taking all these negative Y values and reflecting them up, putting them in the positive position. So this is how we're going to graph the graphs essentially from now on. We're going to graph what we know, and then anything that's underneath the y-axis, or negative y's, right, we are now going to make positive. It's as easy as that. Okay. So, just in case you forgot how to graph a quadratic, we could do a table of values, but I think you're pretty good about this. A function composed of two or more separate functions or pieces, each with a specific domain. So what I'm trying to say, a piecewise function is when I split it up into certain domains, it's two different functions. That's what a piecewise function is. If you take calculus, we talk about piecewise functions a lot, actually. Okay, so who remembers how to graph y equals x squared minus 4? It's a nice basic parabola that got shifted down 4. Yes? So, instead of at 0, 0, now it's at 0, negative 4, 4 down. And then we have the basic parabola after that. Here's my 0, 0, 1, 1, 2, 4, 3, 9. But 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And a mirror on the other side, right? Does everybody remember how to graph this? This is what we did in the first couple of units of this course. We never used a table of values afterwards. We just did our basic parabola shape of 0, 0, 1, 1, 2, 4, 3, 9, yes? And then we just did the transformations after that. Yes? No. For the people that don't know how I got this parabola, yes, you could go back to the basics and get your table of values. If you plug negative 3 in there and you square it, what do I get? 9. 9 minus 4 is 5. Do you see I have negative 3, 5 right there. Negative 2 goes in there. Square it. I get 4. 4 minus 4 is 0. Do you see at negative 2 I have a 0? What's faster, doing a table of values point by point or knowing your basic quadratic and shifting? If I haven't transformed you into that mode, I'm not doing my job. You should be answering the transformation. Negative 1 goes in there. Square it. What do we get?
Negative 3.
Negative 3 at the end. 0 goes in, we square it, then subtract 4. Negative 4. 1 goes in, I square it. Negative 3. 2 goes in, I square it. 0. 3 goes in, I square it. 5. And you know that with the quadratic, you do start, once you get the vertex, do you see the mirror? Do you see the mirror here?
Yes.
Okay, so now the k of x, again, k of x is just f of x with a different letter. It's a fancy name for y. Because the reason why we start naming our functions different, because I don't want to do y little 1, y little 2, y little 3. This is a lot better at labeling, because we're going to have a whole bunch of different functions on one coordinate plane here. So now, if k of x is the absolute value function, what's going to happen to my 5? It's going to stay as 5. What's going to happen to my 0? Stay as 0. What's going to happen to my negative 3 this time? It's going to be positive 3. What about my negative 4? 4. What about my negative 3? 3. What about my 0? 0. What about my 5? 5. Okay, so you can follow that with the table of values. So negative 3, 5, it's still that, right? Negative 2, 0 is still that. But now what happens? Negative 1 is not at negative 3 anymore. Now it's at positive 3. Negative 4 is not there anymore. Now it's at positive 4. 1 is not at negative 3 anymore. Now it's at positive 3. The 0 is still 0. The 3, the 5 is still 5. Now, how does this work? It's not a loop-de-loop. What happens here is essentially the absolute value is cutting off this function at the x-axis and taking this and doing a half reflection up. So what's going to happen here is this is still the same, but it's not going to be a little curvy thing there. It's going to be a jagged edge. Cut off. Then it's going to go up like this. Cut off. Then it's going to go back up like this. Why? How else would you draw it? I see things like this. That's what I see usually, and you will lose marks. It is a jagged edge. It goes to a straight point. No loop-de-doops. Very passionate about it. Huh? It does look like, well. Okie dokie. So let's see if we can say what this function is as a piecewise function. Okay. This is the cool thing about this. Now, watch this. It was the same parabola, but only from -2 to the left and +2 to the right. And what happens in the middle here? Yeah, basically it's the same parabola that just got reflected, right? Like this would continue this way, and it's a parabola going like that. Okay? So I'm going to say it is the regular x squared minus 4. Now this is the tricky part now. But only when x is greater than or equal to 2, sure. And also when x is less than or equal to -2. Yes? Because it's this positive parabola on the left of -2 and on the right of +2. And then what happens in the middle, it is a reflection. Right? It's not just -x squared though. What is it? It's negative the whole thing, right? I'll write it like this. Negative the whole thing. Or, I gotta put this up further, hold on. -x squared plus 4. Does everybody see that? It's actually -x squared plus 4. It's the basic parabola that got shifted up and it's upside down. So when you say a reflection, it's actually reflecting this whole function, which means it's both the x squared and the -4. Yes? And where does that occur? Between. So how do we write that? This is how you write a between. And you might argue, when do you know where to put the equal sign? In this graph, it doesn't really matter because if it's not equal to, it gets filled in by the other function anyways. So if you were to put equals there and not equals there, it would be fine. But it shouldn't be both equals, right? Just make a decision. So what effect does the absolute value have on original function? How did I describe it? So we were more describing it as a reflection, right? I like calling it a half reflection. It's not really a half. I'm going to say that loosely. A half reflection where all negative y values are now positive. It only affects the negative y values, right? Like the positive y values do not become negative y values. It's only negative y values become positive. That's why I'm calling it a half reflection in air quotes. Yes? We good? Okay. So we are now going to graph this. So the way I want you to graph this, no table of values stuff. We're going to graph what we know. Who can tell me what we know? This is not a parabola. It's not a square, so it's not a parabola. What is this? It's a line. So we're going to graph f of x equals 2x minus 3. I know a lot of people don't like f of x. Start getting used to f of x. The whole grade 12 course is f of x, g of x, h of x. F of x is this. Again, f of x is just a fancy name for y. But y was already defined up here. It's not the same thing, right? Yeah? That's why I'm calling it something different. Okay. Who knows how to graph f of x equals 2x minus 3? So we put a point on negative 3, 1, 2, 3. So how's the rise over run? Up 2 over 1. If you want to do another one, up 2 over 1. Up 2 over 1. Do you remember how to do this from grade 10? And then we make the line. Take a ruler and draw our a line goes on forever. So this is f of x equals 2x minus 3. Why are we doing this? Because now we're going to do the half reflection. There's no parabola in this question. This is just a line that gets half reflected. And what's going to happen here? What's going to happen here, people? It's going to bounce right here. So this point right here is going to stay. This is going to stay. And what's going to happen to the rest? It's going to get reflected. So this is at negative 3 right now. So what is it going to go to? Positive 3. And then you can just connect it. So does everybody see? Here is my v, if you can't see. So this is y equals the absolute value of 2x minus 3. The green is my absolute value function. So if you're doing both pencil for both graphs, you need to really label it or erase anything that's underneath the x-axis. Or use a highlighter to highlight my answer. But all this graphing is going to be transformation graphing like this. So you're going to have multiple things on your graph. So you got to figure out how to say the last example. How do you say the final example? Okay. So, I'm sorry? The absolute value function is our final answer. Okay, who can tell me my y-intercept? Okay, what is my y-intercept? Y-intercept. It is 3. Visually, I can see it is 3. But algebraically, how would I get that it is 3? Yeah, set x equal to 0 and solve. So if I put x equal to 0 in for x, what do I get? Oh, I don't get x equal. I get y equals the absolute value of 2 times 0 minus 3. What's 2 times 0? 0, what's 0 minus 3? Minus 3, what's the absolute value of minus 3? 3. So either way, we're getting that the y-intercept is 3. Everybody understood? Okay. For the x-intercept, visually, can you see what it is? Maybe we're not quite sure what it is. However, does everybody see that the x-intercept in this case would be the same x-intercept of this line? So let's find what the x-intercept of the line. How do we do that? Set y equal to 0 and solve. So move the 3 over. So x equals 3 over 2. Does that look like 1.5? Yeah. So therefore the x-intercept, I can't write, hold on. X-intercept is 3 over 2. Okay. What's the domain and range of the absolute value function? What's the domain of the absolute value function? Yeah, negative infinity to infinity. Very good. Okay, what's my range? Yes, 0 to infinity. Very good. That's going to happen every single time because we're not going to have any negative y's, right? No, you have to be able to read set notation, but interval notation is okay. Okay, so now we're going to write this as a piecewise function. If I have any room left, what is y equal to? Well, it's equal to this positive line here. Does everybody see? What's this positive line? 2x minus 3 when x is what? Where does it start? Where does this line start in the green? Right there. What's that x value? 3 over 2. When it's greater than or equal to 3 over 2. And who can tell me the equation of this line going here? Huh? What's that equation of that line? Well, it's got a y-intercept of positive 3. And it's going down 2 over 1. So what is that? Negative 2x plus 3. It should be the opposite signs. That was what we learned before, right? And where does it start? Right there going to the left. So how would we write that? X is less than 3 over 2. Yeah? Okay, do you guys want to try example 4 by yourself? It's just a line again, people. It's just a line. Oh, listen carefully. The first graph we're going to graph is f of x equals 3x plus 1. How do I graph that? I use those slope intercept. Intercept is 1. Put a point. Up 3. 1, 2, 3 over 1. Put a point. Up 3. 1, 2, 3 over 1. Do that a couple of times because you need some points as reference, right? So, how do I get the points below? Instead of going up 3 over 1, I'm going to go down 3. 1, 2, 3, left 1. Down 3, 1, 2, 3, left 1. Does everybody see? Now, I saw some of you are really good. Instead of drawing this entire line, they only drew the line up to the x-axis. That's good, because then you don't have to erase anything, right? If you know that this is eventually going to be reflected, you could get to that point. I'm not going to do that because I saw still a lot of people doing this, so I'm going to do it this way. Okay, I should be using a ruler. Shame on me. Okay, then I'm going to take my different colored pen, right? Different colored pencil. And I'm going to, does everybody see the absolute value is the same as this line up to the x-axis, not the y-axis. I saw some people cutting it off of the y-axis. It's the x-axis. Why is it at the x-axis? That's where the y's now become negative. After this x-axis, they're all negative zone, right? Does that make sense why we're cutting it off the x-axis? Okay. So now, this negative 2 is now going to be positive 2. This negative 5 is now going to be positive 5. And bada bing, but it's a little bit off here. That's okay. Bada bing, bada boom, there's my line. Maybe I'll make it a little thicker here so you can see it's a 2, it's a 5 there. Maybe you can't see that. Okay? Make sure you have arrows. Now the easiest way, if it's not actually going through a point that you can just read it off the graph to find the y-intercept, look at your old graph. Everybody knows, because you got out of grade 10 intro, how to find the x and the y-intercept of a line, right? So use this line to figure it out. So how do I find the x-intercept? I set y to 0. 0 equals 3x plus 1 minus 1 equals 3x. So x-intercept is negative 1/3. So negative 1/3. What's my y-intercept? My y-intercept should be the y-intercept of this line. I can read it. What is it? 1. What's my domain and range? Yeah. And what is my range? I hear 1 to infinity. No. It It's always going to be 0 to infinity because I can include 0 in the absolute value. I cannot include any negatives, right? What's my piecewise function? So y is equal to the line 3x plus 1 when x is greater than or equal to what? Negative 1/3. And it's equal to what? When x is less than negative 1/3. Very good. Okay, let's move on. What do we have now? It's a quadratic. How do we graph quadratics? Let's go back to September. How do we graph quadratics if it's in this form? Complete the square. Complete the square. Y equals negative x squared plus 2x plus 8. What do we do first? Take out the negative, bracket x squared minus 2x. Leave a space, plus 8. Anybody get lost there? Huh? Okay, now we're going to complete the square. So we take half of the middle term, which is 1. I square it is plus 1. But did I actually add 1 here? No, I actually subtracted 1. So how do I compensate a subtraction of 1? I add 1. So I have plus 9 here. Okay, is everybody good? Look at that. Refresh your memory. You'll have to know this for the end of the course anyway, so this is great review. Who can tell me what happened to my basic parabola? Who can tell me what happened to this basic parabola? It got shifted. Right 1, up 9, and it's now upside down. Okay, so let's graph this. Right 1, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's the second highest there. And now it's upside down. Can you draw an upside down basic? Just pretend this is 0, 0. Instead of going right 1, up 1, you're going to go right 1, down 1. Do you see? And instead of going right 2, up 4, we're going to go right 2, down 4. There's my rest there. Oops, I'm not hitting my points here. Okay, instead of going, and usually we would stop right there, right? But I know because I'm going to have to reflect, I want to do one more. I'm going to do 3, 9, right? So, right 3, 1, 2, 3, down 9. Well, that's where it hits the x-axis. Look at that. Isn't it a beauty? Yes. There is my y equals negative x squared plus 2x plus 8. This is also where anybody that had trouble graphing quadratics is going to bite you in the bullet now, right? It's biting you in the butt, I guess. It wouldn't be biting you in the bullet. Anyways. Okay, so now how do we graph the absolute value? Cut it off at the x-axis. And what happens to the stuff that's underneath? Oh, it's not gone. It's gone so down there, but where did it go? Up. So this is going to be the same. Everybody see this is going to be the same? And then it's just going to go back up. Jagged. Jagged, right? Cut it off, not a little loop-de-doop. You're going to lose loop-de-doop. I'm going to actually call it loop-de-doop. Minus a half. We need a new counter of loop-de-doops instead of puppies, yes. Okay. What's the y-intercept? What's the y-intercept? It is 8. Even if you couldn't read it there, you put 0 in for x. It's 8, right? It's very noticeable when it's in that form. What's my x-intercept? What's my x-intercept? Stop it. Try again. How about negative 2 and 1, 2, 3, 4? Okay, say you couldn't read it off the graph. How do you find your x-intercepts? Set y to 0 of this upside down parabola. That is this, right? I think I want to set it back to here. So 0 equals negative x squared plus 2x plus 8. How do I solve my x-intercepts? Factor. Now, I would never try to factor a negative x squared. What's the trick when it's an equal sign there? Switch all the signs. Yes, so 0 equals x squared minus 2x minus 8. This factors beautifully to be what? X minus 4, x plus 2. So what does x equal? 4 and minus 2. Exactly what I got over there. Do you see that? Yes? Do you see everything we've learned is now all coming together? Everything. Yep. While we're waiting 1 second, let's discuss our domain and range. Oh my gosh, I don't think I can handle that. Hey, it's the same answer every single time. What do you know? This is gimme marks, you guys. Seriously, these are gimme marks at this point, right? Okay. And the hardest part, I guess, would be the other thing. So, the piecewise function. So, f of x is going to equal two different things. So, it's the upside down parabola, which is negative x squared plus 2x plus 8 when what happens? It's the upside down parabola when it's between those two x-intercepts, right? So, negative 2, do you see that? When it's between negative 2 and 4? Now, what would be the reflected one, the other one there? X squared minus 2x minus 8 when? So when it's less than negative 2 and greater than or greater than 4. So when x is less than negative 2, comma, when x is greater than 4. Yeah? How are we doing? If you understand the piecewise function when we do Monday's lesson, it'll make a lot of sense. Right? It'll make a lot of sense. Okay. Keep going. 5 minutes. Let's go. How do we graph this? How do we graph x squared minus x minus 2? I'll show you another trick for graphing quadratics. If I were to complete the square right now, I'm going to get some fractions, and I know you guys don't like fractions, right? Yeah? Well, we could. So let's graph y equals x squared minus x minus 2. So we got to take half of that. So what's half of that? A half. If I square a half, what am I doing? What's 1/2 times 1/2? I think you guys like the decimals, didn't you? You like a quarter? So did I add a quarter here? Sorry, I need to move this minus 2 over, right? I'm going to put minus 2 over here. I actually added a quarter. That's this part of that. So what do I have to do to compensate for this adding of a quarter? I got to subtract a quarter. So what do you get when you combine negative 2 and negative a quarter? Negative 2 1/4. And if you don't know what negative 2 1/4 is, write it down and then do 4 times 2 plus 1. So what is it? Negative 9/4. So that's that. So let's do our vertex. Our vertex is it. As our basic parabola is at right a half, down 2 1/4. 1, 2 1/4, halfway. Now this is going to be rough now. Try to do it pretty rough, right? So there it is. I'm going to go right 1, up 1. Right 1, up 1. Right 2, 1, 2, up 2, 1, 2. Right there? Sorry. Okay, we'll try it again. Watch this. This parabola got shifted to the right a half, and down 2 1/4. 1, 2 1/4. My pen is just a little bit, it can't hit the quarter very good. It's not that precise. Does everybody see how I got that 0, 0 spot? So now I'm going to go right 1, right, up 1. Stay there and there. Then I'm going to go right 2, 1, 2, up 4. 1, 2, 3, 4, something like that. And then I'm going to go bada bing, bada boom. And then, how do I draw the rest? How do I draw the rest, people? This stays the same, and this gets reflected. So it's going to be bada bing. There you go. So this one, on a test, I'll probably give you more exact points because I want to see where you hit it. But really, in the end, you got to get the gist of it, right? Like if it's 2 1/4 and you got a 2 1/3, who cares? Like I want to get around the same area, right? Okay, domain and range. Easy. Oh, do I even have to ask anymore? Okay, I just want to get it through yourself, that through your skulls, that it's always the same. Okay, piecewise function. Piecewise function. F of x equals x squared minus x minus 2 when x is what? When are they the same? Oh, we don't know what our x-intercepts are. It looks like that, but I don't actually know what the x-intercepts are. How do I find the x-intercept? Solve it. Y goes to 0. So 0 equals x squared minus x minus 2. This factors beautifully. What is it? 2 and 1. So it is actually what it says. So it's the it's the right side parabola when x is less than 1 and greater than 2. It should be -1. I don't know why I don't have a negative in there. And when is this? This is the reflection part of that one. So it's going to be negative x squared plus x plus 2 when x is between -1 and 2. I'm going to put equal sign on that one because I didn't put it on the other one. It doesn't matter which one you put the equal sign on because they all fill in. Okay. The x-intercept is, 2 and -1, and what's my y-intercept? What's that? The absolute value of -2, which is 2. Yeah? Okay. Thank you. I like these. This is how most of grade 12 is. They give you an actual function that's already graphed, and you just need to do the transformation. So, how do we do it? Everything that's above stays the same. Does everybody see that? Yeah. And what happens with the part underneath?
Great jacket.
Yeah. So reflect that one how low it goes, right, Matthew? Goes up here. Bada bing, bada boom. Jagged. Done.
Okay.
That's it. You love these kind because you don't have to do the first graph, right? Okay, what happens here with this wavy thing? It is. It's jagged right there. Jagged, jagged. Okay, what happens here? Anything above stays the same. Stays the same. Stays the same. Does everybody see how I'm doing this? Now what's going to happen? Right here gets reflected. 1, 2, 3, 1, 2, 3. Jagged. 1, 2, 3, 1, 2, 3. Jagged. 1, 2, 3, 1, 2, 3. I'm just getting the height so I know. There it is. It looks like a worm. No?